Hello friends, this is Aryan. Today we are going to discuss about delta modulation. Now what is the importance of delta modulation is that it is a process where we convert an analog signal to digital data. Now what is the reason that we have come out of analog delta modulation is that for converting your analog signal to digital data, people used to have pulse code modulation, but the complexity associated with your pulse code modulation is very high. So to overcome that one, we have delta modulation for converting your analog signal to digital signal. In case of your pulse code modulation PCM, the output is your group of bits, whereas in delta modulation we generate stream of bits. And in delta modulation we have two steps. One is modulator at the sender side and demodulator at the receiver side. The modulator at the sender side takes the input as an analog signal, and with the help of comparator and delay unit and staircase maker, it generates digital data. And demodulator at the receiver end takes the input of digital data, and with the help of staircase maker and delay unit, it generates analog signal. Okay, now this delta means small positive or negative changes that occurs when an input signal is compared with an existing digital signal. Now before we get in detail, let us discuss how exactly your modulator work and demodulator work. This is what is the diagram of modulation technique in a delta modulation, where it takes an analog signal and this modulator creates a second signal that resembles a staircase. Then whenever an existing staircase signal and the signal created by the modulator is compared, if their difference is positive, then it generates bit 1. If their difference is negative, then it is going to generate 0. And in this way the modulator is going to work and it creates your digital data. Coming to demodulator, in this case the input here is your digital data, where the staircase maker with the help of delay unit generates a staircase signal, and this staircase signal is finally passed through a low pass filter to create your analog signal. And if we compare the quantization error associated with the delta modulation and the quantization error associated with PCM, then PCM has higher quantization error compared to delta modulation, and delta modulation is much more simpler as compared to your pulse code modulation. So these are the basic things about delta modulation and the working principle of your delta modulation. Then one more thing that we can discuss in delta modulation is that whenever the modulator creates a staircase signal, when it compares with an existing staircase signal, sometimes there is a chance of error, because there is no dynamicity in case of your existing staircase signal. So depending upon the input analog signal, there should be an adaptive DM where it should create a staircase signal of dynamic in nature, where the staircase signal created by your modulator and the existing staircase signal should be compared in such a way that the bit or stream of bit that is generated out of modulator should be perfect. So the motive of telling all this thing is that normally delta modulation staircase signal never changes. So we need to employ an adaptivity in that delta modulation technique so that the staircase signal that is compared with each analog signal must be changing so that perfect bits will be generated. And this is all about delta modulation. This is brief. If you want more, you can write to me, you can subscribe my channel and like my channel. Thank you all. Hi friends, this is Aryan. Today we are going to learn analog transmission. Analog transmission mainly consists of transmitting your digital data by using your bandpass channel. So particularly analog transmission consists of two parts. One is converting your digital data to bandpass analog signal and converting your low pass analog signal to bandpass analog signal. Concerning this, what happens exactly when we convert a digital data to a bandpass analog signal is that we normally map the digital data with any of the signal characteristics like your amplitude, phase or frequency, so that can be transmitted through your bandpass analog channel. And this kind of mapping is also done in case of your low pass analog signal to bandpass analog signal conversion, where the low pass analog signal information has been converted into bandpass analog signal and they are transmitted through a communication channel. Now, representation of analog information by an analog signal is known as analog to analog conversion. So first of all, let us try to see how exactly digital data has been converted into bandpass analog signal and what are the different techniques available to perform digital data to bandpass analog signal conversion. Now, in this figure, we observe that there is a sender and there is a receiver, where the sender has digital data and at the sender side we have modulator. The duty of this modulator is it converts the digital data to bandpass analog signal and passes through a communication channel. Once it is received at the receiver end, the digital signal that has been converted into analog signal at the sender end has been demodulated. That is, the analog signal has been converted into digital data and delivered to the receiver. This is how exactly the process of digital data to bandpass analog signal conversion takes place. Under this scheme, there are different techniques available. One is amplitude shift keying, where the digital data is mapped with the amplitude of the signal, and that is passed through a communication channel. Then we have frequency shift keying, where the digital data is mapped with the frequency of analog signal, and that is passed. And the third one, we have phase shift keying, where digital data is mapped with phase of analog signal, and that is being transmitted through a communication channel. And among all these, we have one more advanced concept, where that is your quadrature amplitude modulation, where it combines the features of amplitude shift keying and phase shift keying, and maps your digital data to your analog signal, and that is being passed to the communication channel to the destination. And this quadrature amplitude modulation is what we commonly used in your day-to-day life. Rest everything, they are only for knowledge sake. But still, there are some places where these techniques are being used, but the quadrature amplitude modulation widely used in current scenario. This is how the few techniques that deals with converting your digital data to analog signal, that is mapping of digital data to band pass analog signal. Then we have analog to analog conversion, where we convert analog signal, low pass analog signal, to band pass analog signal. Under this scheme, we have three different techniques. One is your amplitude modulation, then frequency modulation, then phase modulation. The same way, by varying amplitude, we can generate different signal element. By varying the frequency, we can generate different signals, and by varying the phase, we can generate different signals. Once these signals have been generated, they are being passed through a communication channel and sent to the destination. Friends, these are all about a few things that we need to know about conversion of analog signal, conversion of your digital data to analog signal, and conversion of low pass analog signal to band pass analog signal. If you want more on this, please subscribe my channel and like my channel. Thank you all for watching my channel.